more water fun. Hey, Jason here. Let's get started. Hydrology, the study of water, by Christine Taylor Butler. Water exists all around us. It is in the air, on the ground, and deep below the surface of Earth. We cook with it, play in it, and bathe with it. When you take a drink of water, do you ever wonder where it came from? Do you wonder why the water that gives us life can also destroy a city? Scientists ask these same questions. Fact: Niagara Falls consists of 3 separate falls: the American, Bridal Veil, and Canadian Horseshoe Falls. Hydrology is the study of water on Earth. Scientists study how water behaves 3S when it is a liquid, a solid, or a gas. They conduct experiments to find out where water travels and where it is stored on and beneath Earth's surface. Scientists also look for ways to use water to help people. They also look for ways to conserve it. Scientists who study water are called hydrologists. Hydrologists collect a lot of data. For example, they measure rainfall and snowfall. They use their measurements to predict where the rainwater and melted snow will go. Too much rain can cause rivers to overflow. The water may flood farmlands and cities. Rain that flows downstream from the mountains or other places is called runoff. Hydrologists pay attention to runoff levels and help issue flood warnings. Then people have time to prepare for an emergency. Too little rain can cause a drought. Desert states such as Arizona and Nevada could not survive without a constant source of water. Hydrologists help design dams that back up large rivers and capture water. This water can then be stored in a storage area called a reservoir until it is needed in an area that has too little water. Hydrologists teach communities in desert areas how to plant gardens that conserve water. They identify plants that require very little water to survive. Using these plants helps people use less water. Hydrologists also help farmers water their crops through irrigation. They study how water moves over and through the ground. This helps hydrologists make sure that fertilizers and pesticides used on the crops don't flow into lakes and streams. This would harm wildlife. Fact: more than 75% of all water used in the world is for irrigation. For thousands of years, hydrologists had looked for ways to control water. They knew that heavy rain or snowfall in one region could cause serious flooding in other areas downstream. They designed canals, levees, and dikes to protect towns and farmland. They built underground pipes to transfer water to cities. They used water to power machines. We still use many of these methods today. The Romans used aqueducts to bring water to cities. The first aqueduct was built in 321. Aqueducts use gravity to move water through the system. If the water needed to travel down through a valley and then uphill, engineers used siphons. The water traveled across the valley and up through a closed pipe. The weight of the water pushed the water through the pipe to almost the same height on the other side. Civilizations as far back as the ancient Greeks learned how to harness the power of water to produce energy. Water wheels used the power of moving water to turn machinery and grind wheat. Modern scientists use this process to create renewable forms of energy. Falling water can create enough electricity to power cities hundreds of miles away. In the early 1800s, scientists began to understand that the rain falling from the sky began as water in the oceans. French engineer Henri Philibert Gaspard Darcy demonstrated how water flows through objects that seem solid, such as soil or porous, holy rock. He knew that the same principles could be used to understand how water travels through the ground. Darcy invented the modern pitted tube, a device used to measure water flow. Floods can sometimes be useful. Flood irrigation was first used in Egypt when the Nile overflowed each summer and fall. The floodwaters carried fertile soil to farmland along the banks. Early hydrologists helped farmers plan crops around the wet and dry seasonal changes. Floodwater is used in China to irrigate rice paddies. The roots of the rice plant grow best when covered with water. For more than 2,000 years, hydrologists and engineers in the Netherlands built dikes and canals to keep seawater from flooding towns. Windmills were used to pump water back to the sea. Today, electric pumps are used. In 1953, a storm raised the sea level several feet. More than 1,800 people were killed. Engineers designed better ways to control floods. Dutch dikes are now the strongest in the world. Levees can be built to protect towns located below sea level. On August 29, 2005, Hurricane Katrina hit New Orleans, Louisiana. The water did not flow over the levee. Instead, the force of the water moved the soil beneath the levees. The levees collapsed, and water flooded 80% of the city. The U.S. Army Corps of Engineers is building stronger levees using methods invented in Holland. Hoover Dam is located on the Colorado River in the Black Canyon, near the Arizona-Nevada border. Construction crews worked for more than 5 years to build it. Before it was completed in 1936, land downstream was dry for most of the year. Each spring, the river swelled from snow melting in the Rocky Mountains. Hoover Dam controls seasonal flooding by holding water back until it is needed downstream. Inside the dam, water is pumped through a system that creates electricity for Nevada, Arizona, and California. All life on the planet depends on the water cycle. This process is also called the hydrologic cycle. This cycle is responsible for weather patterns and climate. Hydrologists study the cycle to look for changes in the pattern that might create emergencies or make water unsafe for humans and animals. The hydrologic cycle has no beginning or end. The hydrologic cycle has 5 basic parts. They are evaporation, transpiration, condensation, precipitation, and collection. Evaporation is the process when the energy from the sun warms Earth's liquid water and turns it into water vapor in the air. Liquid water covers about 70% of Earth. It is in oceans, rivers, lakes, and other bodies of water. The soil also contains some water. Evaporation and transpiration are related. Plants add to the water vapor in the air through transpiration. A plant draws water from the soil through its roots. The plant uses some of the water. The rest of the water evaporates through the leaves or needles. All of this water vapor mixes with the air. This creates humidity. Humidity is a measure of how much water vapor is in the air. Warm air rises. Water vapor rises with it. As the air travels away from Earth, it cools. Cool air cannot hold as much humidity as warm air can. Eventually, the air reaches a temperature where water vapor turns into liquid droplets. This process is called condensation. As more water vapor becomes liquid, the droplets gather into clouds. Wind pushes the clouds to different locations on the planet. The water droplets continue to collect into bigger and heavier clouds. Soon, the droplets become heavy enough to fall back to Earth. This falling water is precipitation. It often falls as rain. In colder temperatures, precipitation might fall as snow, sleet, or hail. Some precipitation falls directly into rivers, lakes, or oceans. Some falls on land. When precipitation falls on land, some of the water flows downhill, eventually collecting in rivers or lakes. Much of the water soaks into soil. Plants draw part of the water through their roots. The rest continues down into the ground to collect aquifers. Whether the precipitation falls on water or land, the hydrologic cycle begins again. Humans need fresh water to live. They cannot drink the salt water of the oceans, but only about 3% of Earth's water is fresh water. Hydrologists study aquifers to look for fresh water sources. They study groundwater to find out if it is contaminated with pesticides or toxic materials. Hydrologists help cities design sewers to carry away water during storms. They design equipment to purify water that can be used for drinking. Hydrology plays an important role in keeping the planet healthy. Major problem in many African nations. A water molecule is made from 2 hydrogen atoms and 1 oxygen atom. The chemical formula for water is H2. H stands for hydrogen. O stands for oxygen. Water is a unique substance. It is the only type of matter that naturally exists on Earth in 3 different states: liquid, solid, and gas. Water molecules can slide over one another. That is why liquid water takes the shape of any container it fills. When heat is applied, the molecules move farther apart. Eventually, the bonds connecting water molecules to one another break. Water becomes gas vapor when the temperature reaches 212 degrees Fahrenheit. When the temperature cools, water molecules slow down. If the temperature falls below 32 degrees Fahrenheit, the water molecules lock in place and form solid ice. This is called the freezing point. When the temperature rises above the freezing point, the ice melts and becomes a liquid or vapor once again. Water has an unusual property. Its volume expands when it freezes. Water can break a metal pipe if it is trapped inside when it freezes. Pure water has no taste, color, or odor. The water in your glass, however, is not pure. It contains dissolved minerals and chemicals. Minerals get into the water when it filters through the ground. Chemicals are sometimes added to make the water safe for human use. Seawater is also unpure. Salt is mixed in. Humans cannot survive on salt water, but ocean creatures can. Some animals' bodies filter the salt out of the water. Others get the water they need from their food. Water is heavy. Gravity pulls water downhill until something gets in the way to stop it. When dropped from a tall height, water can drive a turbine. Water is also a solvent. It can seep into porous objects and dissolve them. This is why some materials break down when exposed to water. Hydrologists study these properties to design experiments. Their studies can lead to safe drinking water and better use of resources. Hydrology plays an important role in keeping the planet healthy. Hydrologists work with engineers and other scientists to design solutions to some of the world's problems. They find ways to create renewable sources of energy. They help design devices that alert the public to potential dangers when bad weather arrives. Hydrologists are even helping NASA study the frozen water on Mars. Hydrologists are constantly inventing new ways to control water. Venice, Italy, was built in a lagoon. A lagoon is a shallow body of water that is connected to the sea. Venice's buildings are sinking. The sea level is rising. In 1996, Venice flooded 100 times. The first floors of most buildings in Venice are no longer usable. Hydrologists have developed a way to prevent more flooding. They designed gates that rise out of the water when a high tide approaches, blocking the water. The gates lower when the water level goes down. In New York, hydrologists helped design underwater turbines that work much like windmills. The turbines spin below the East River when the tide flows toward the land. They spin again when the tide rolls back out to sea. This creates a source of clean, renewable energy. Scientists are studying the data to make sure fish are not harmed. Arizona receives a share of the water from the Colorado River. Because the state does not use its full amount, the government created a water bank. This guarantees that water is available to use in times of drought. Some water is stored in an aquifer. The rest is used to irrigate crops so farms do not have to pump water from underground. Drought is a major problem in many African nations. In some places, people must walk several miles to collect water. The water is often used by wildlife and many be contaminated. Hydrologists use solutions created in other parts of the world to help solve this problem. Using towers or bugs to collect rain helps provide a cleaner source of water. So you want to be a hydrologist? Hydrologists study math, geology, biology, and engineering in college. They use those skills to solve problems. They spend a lot of time outdoors. Hydrologists use gauges, flow meters, pumps, and many other scientific tools to collect and analyze water data. If you want to be a hydrologist, be prepared to get wet.